We are in section 8.2, testing claim about a proportion. Remember the best point estimate for P, the proportion of population with a certain characteristic, is given by P hat equals X over N, and this is where X is the number of individuals in a sample with a certain characteristic, and N is going to be our sample size. This is going to be approximately normal with mean equal to P, and a standard deviation equal to the square root of P times 1 minus P divided by N. And this is only if the following requirements are satisfied. And so these are definitely requirements we need to check. The first thing is going to be that the sample is going to be a simple random sample. The second is going to be that the conditions for the binomial distribution are satisfied. So make sure you go back and look for this. There should be 4 different things that you need to check in order to make sure that something satisfies a binomial distribution. And then n times p and n times q both have to be greater than or equal to 5. And if we have all of that, and the test statistic for testing claim about proportion is, and we have z equals p hat minus p divided by our standard deviation, which is the square root of p times 1 minus p divided by n. So right below this we have a box with our calculator steps in it. And so to test the hypothesis regarding a population proportion, this is again using that p-value approach, which we focus on, with an 83 or 84 calculator, we're going to use the following steps provided that, and this is again what you would have to check, especially when you do your own project for the class. These are the conditions that have to be met in order for this test to be conducted. And so the first one is simple random sample for our sample. And the conditions for the binomial distribution are satisfied. Again, 4 things that you need to look up and check. N times P and N times Q are going to both be greater than or equal to 5. Step 1 is determining your null and alternative hypotheses. This is going to be depending upon if it's two-tailed, left-tailed, or right-tailed test. Step 2 is going to be selecting that level of significance. And usually this is going to be given to us. Step 3 is finding our p-value and test statistic if necessary, enter raw data into L1. So we're going to go to stat, our stats button, go over to test. We're going to go down to number 5. Number 5 is our 1 prop z test. 1 prop standing for 1 proportion, z because that's our distribution that we're using, test. And we need to enter in P naught, which is the value of the population proportion in the null hypothesis, X, which is our number of successes, and then N, which is our sample size. You're going to select the direction for the alternative hypothesis, which is either going to be not equal to, less than, or greater than your P naught value. Then you can highlight calculate or draw. Draw is kind of neat to see it draw that bell-shaped curve for you. But calculate, press enter. When you do, you're going to get 2 different things that we need in our output. A lot of times different questions will ask for a test statistic, so make sure to state that. And then P or p-value, which is what we need in order to use that p-value approach to test the hypothesis. And so if the p-value is less than alpha, we are going to reject our null hypothesis. And then our last step is going to be to state a conclusion. So we have a nicer example right below this. And this one says, test the hypothesis using the p-value approach. And it says, assume the testing criteria has been met. So we're going to assume that testing criteria has been met, so we don't have to check those 3 requirements listed up above. And so we are given our null and our alternative. So our null is going to be p is equal to 0.6, and our alternative is going to be p is less than 0.6. On the calculator, you're going to go to stat, to test, to 1 prop z test, enter in the value for p naught, x, and n. All of those are given. And then you're going to get your p-value, and notice that since it has the e negative 22, it's going to be times 10 to the negative 22nd, and that's going to round to 0. So on your calculator, you get a p-value equal to 0, which is less than alpha, and alpha was given to us, which is 0.05. And since your p-value is less than alpha, we are going to reject H naught. And so now we need to state our conclusion. So we're going to start off with there is sufficient evidence. So sufficient evidence. And I'm going to go ahead and say at the alpha equals level of significance. To conclude that, and again, we always talk about our alternative hypothesis. And so to conclude that we will, it's reject the null hypothesis. The example right below this is going to be more along the lines of what we will see. It's more of a word problem. And so for this, the first example of this page says the drug Lipitor is meant to reduce total cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complained of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha equals 0.01 level of significance? So this time it does not say that our testing criteria has been met, so we will have to check that. But before we do that, let's just go ahead and write down some of the numbers that are given. And so we have a sample size here, which is n. And n is going to be 863 people. And we have a sample size of 19 people out of that had those flu-like symptoms. So that's our x value that had that characteristic. And this one is flu-like symptoms. And we have our proportion or our probability, which is going to be that 1.9%. which is going to be 0.019 as it's written as a decimal. And then Q, which is going to be 1 minus this, is going to be 0.981. So again, in order to conduct this, it has to meet those criteria that are listed on the previous page. And so we're just going to briefly talk about that. So definitely to make notes, write it down. So first thing is it has to be a simple random sample. It looks like it is. They're randomly selecting people. The binomial distribution has to be met, those criteria. And so we have a fixed number of trials and they're independent. So we have 863 independent trials. We have a fixed probability of 0.019. And there's two outcomes for this. They either have those flu-like symptoms or they do not. So that binomial criteria would be met. And then the other thing that we have to check is going to be n times p, and n times q is greater than or equal to 5. And so I'll jot that down right up above. So we have n times p has to be greater than or equal to 5, and then n times q has to be greater than or equal to 5 also. So 863 times p, which is 0.1019. When you work this out, you get 16.4, which is greater than or equal to 5, so check. And then n times q, so 863 times q, which is 0.981, which works out to be 846, which is greater than or equal to 5. So all the testing criteria is met. Therefore, we can do this test, and since we're dealing with proportions, we need to write down our null and alternative hypothesis. So H0 and H1. Since these are proportions, I'm going to go ahead and put P's. We know our null would be an equal sign. And it does say to conclude that more than 1.9% of Lipitor users experience flu-like symptoms. So our H1 would be greater than, and that decimal value that's going to go in there is going to be our 0.019. So we're going to use one prop z test on our calculator. On your graphing calculator, you're going to go to Stat, to Test, down to one prop z test, and you need to enter in your p0 value, which is 0.019, your x value, which is 19, n, which is 863, and then you need to select your alternative hypothesis, which is going to be that it is greater than p0 for this problem, and select enter. The app that I'm using is going to draw our bell-shaped curve, which is nice to see, and our p-value is going to be 0.2582 if we round 4 decimal places. And so on the calculator, we get a p-value equal to 0.2582, which is, if we compare this to alpha, and alpha was equal to 0.01. We have our p-value is going to be greater than alpha, and this means that we do not reject H0. So from here we need to write a conclusion, and so it's going to start with there is not sufficient evidence. So there is not sufficient evidence. Again, we're at the alpha equals 0.01 level of significance. To conclude that, and for us it's going to be to conclude that more than 1.9% of Lipitor users experience flu-like symptoms. Again, we always discuss H1. So to conclude that more than 1.9% of Lipitor users experience flu-like symptoms. And the wording is right up above here with what we were testing. So the example right below this says in 2000, 58% of females aged 15 years old or older lived alone. According to the U.S. Census Bureau, a sociologist tests whether the percentage is different today by conducting a random sample of 500 females aged 15 years of age and older, and finds that 285 of them are living alone. Is there sufficient evidence using alpha equals 0.1 level of significance to conclude that the proportion has changed since 2000? This one then says, assume the testing criteria has been met. So we can just go ahead and say everything's been met. Let's go ahead and write down our null and our alternative hypotheses. Since we're talking about 58% and we're dealing with a proportion, I'm going to go ahead and write down P here. And equal sign for our null. Our alternative, it does use the word different, is different today to conclude that it has changed. And so our alternative would be not equals to. And that proportion is 58% or 0.58. On your graphing calculator, you're going to go to Stat, scroll over to Test, find one prop z test, and we need to enter in our values. For P0, we have 0.58. For X, we have 285 out of our sample, which is N of 500. Make sure to select your alternative hypotheses of not equal to, and when you do that, you will get a p-value of 0.6505. From our calculator, we get a p-value equal to 0.6505. And we have to compare this to alpha, which for this case is 0.1, and that was given to us in our problem. And this is definitely greater than, our p-value is definitely greater than alpha. And so this means that we do not reject H0. And so our conclusion is going to be there is not sufficient evidence at the, and then our level of significance is alpha equals 0.1 level of significance to conclude that the proportion of females living alone has changed since 2000. Which again is what we are discussing with our alternative hypothesis. And it says that here the proportion has changed since year 2000, and again we're talking about females living alone. So the next example that we have on this page says data collected from M&Ms list 100 M&Ms and 34% of them are blue. The Mars Candy Company claims that the percentage of blue M&Ms is equal to 0.24 or 24%. Use a 0.05 significance level to test the claim. Should the Mars Company take corrective action? And so this one does not state that the testing criteria has been met. The first thing is N is our sample size, and we have 100 M&Ms. And X is going to be the number that are blue. And so for this one, it says there's 134% of them are blue. So 100 times that 34% would mean that 34 of them out of those 100 are blue. And they are saying that the Mars Company is saying that the percentage of blue M&Ms, or P, should be equal to 24% or 0.24. And this means that then Q would be equal to 1 minus this, which is going to be 0.76. So again, making sure those criteria have been met. First thing is it's a simple random sample. These are M&Ms, it should be. We have a fixed number of trials, 100 of them. They're independent, fixed probability of 0.24. And two outcomes, they're either blue or they're not blue. And then the last thing that we would have to check is going to be N times P is greater than or equal to 5, and then N times Q is greater than or equal to 5. And again, N is 100, P is 0.24, and so we get 24, which is greater than or equal to 5, and then 100 times Q, which is 0.76. So 76 is definitely greater than or equal to 5. So both of those check. So our criteria has been met and we can perform this test. So the next thing we need to do is write down our null and our alternative. Since we're dealing with proportion of blue M&Ms, I'm going to go ahead and put a P for both of these. An equal sign for our null. And for our alternative, it doesn't say anything clearly along the lines of something being more or less than. And I don't need to make an assumption about it. So since we don't know, it's going to be not equals to, and that percentage that we have for P is 0.24. On your graphing calculator, you're going to go to Stat, to Test, to one prop Z test. Enter in your values. So our P naught value is 0.24, X is 34, and our sample was 100, so N is 100. Our alternative hypothesis is not equal to, so make sure you select that. From our calculator, we get a p-value equal to 0.0192. And we have to compare this to alpha, and alpha this time for our significance level is 0.05, and so this is less than alpha. Our p-value is less than alpha. And since that p-value is lower, the chance of it occurring randomly when the null is true is really small. That means we're going to reject H naught. And so then writing our conclusion, we're going to say there is sufficient evidence and this is at the alpha equals 0.05 level of significance, to conclude that the proportion of blue M&Ms is not equal to, or I'm going to use the word different, is different than what the company says, which is 24%. And so since we are showing that it is not equal to, we have enough evidence to support that, not equal to the 24%, it says, should Mars company take corrective action? It looks like there's an issue with what Mars company is saying and what we're actually getting. So yes, you want to make sure that this is okay. So we have another example on the next page. And so for this one, this says, the question was posted on the American online website, do you believe the Loch Ness Monster exists? Among 21,346 responses, 64% said yes. Use a 0.1 level of significance to test the claim that a majority of people believe that the Loch Ness Monster exists. Use a confidence interval approach and assume that the criteria for the test has been met. So this time it wants us to use the confidence interval approach, and then it also tells us that the criteria for the test has been met, so we don't have to worry about that. So first thing we're going to do is set up our null and alternative. We still have to do that no matter what approach we're using. And I don't see any percents on here, but we do have a word that we might see, and it is majority. So what a majority means is more than half, so more than 50%. So more than half of the people believe that the Loch Ness Monster exists. So proportions for H0 and H1, an equal sign for our null, and it's equal to 0.50. And it says that we use the 0.01 level of significance to test the claim that a majority, so more than 50%, so greater than 50% or 0.50, believe in the Loch Ness Monster. And so we need to go to one prop z int, but before we do that, since it does want us to use an interval approach, I just want to draw our bell-shaped curve so we can think about this. And so since this is a right-tailed test, I know that alpha is going to go in my right tail. And so alpha is equal to 0.01. However, the issue is that with confidence intervals, we need to have it set up as a two-tailed test. That's by definition, remember the plus and minus that we had, that idea that there's a little bit of error on the left side and a little bit of error on that right side. And so in order to do that, I'm going to go ahead and switch colors here. I'm going to put another line over here, and this area over here is also going to be equal to 0.01. So we have the right side, which was what we have because it's a right-tailed test. And then we have to make this be a confidence interval, so I need to make the left side be the same. And remember that that bell-shaped curve is symmetric. And so what is the area inside this bell-shaped curve? Well, since the total area under the bell-shaped curve is equal to 1, minus that 0.01 and the other 0.01, we get 0.98. Our x value that we need to put in, and our n value that we need to put in, and then our C level, which we will also need to put in on our calculator. And so x is going to be equal to the number of people that believe that the Loch Ness Monster exists. And we surveyed quite a few people, 21,346. So that would be our N. And it does say that out of the 21,346 responses, 64% said yes, they believe that he exists. So I'm going to say 21,346 times that 64%, writing it as a decimal, so 0.64. So we get 13,661.44. Since that's not a full person there, 0.44 is not a whole person, this is going to round to 13,661 for our x value. And then our confidence level is going to be that middle part on our bell-shaped curve, which is 0.98. On your graphing calculator, you need to go to Stat, to Test, to 1prop_z int this time since we're dealing with intervals. And our x value that we calculated was 13,661. Our n value, our sample, was 21,346. And then our confidence level for this problem was 0.98. Or you can just type 98. Select enter from there. And when you do, you're going to get a lower bound and an upper bound. And so the lower bound, rounding 3 decimal places, would be 0.632. And the upper bound is going to round to 0.648. And from the calculator, we get 0.632, 0.648. And looking at this, the p-value that we did have up here is 0.5, and it's not in this interval. So since 0.50 is not in the confidence interval, this means that we do not reject H0. And so from here we could write a conclusion and say that there is not sufficient evidence at the alpha equals 0.01 level of significance to conclude that a majority of people believe in the Loch Ness Monster existing. I don't have enough space to write it down, but again, feel free to write down your own conclusion in your own words, but it should be along the lines of there is not sufficient evidence at the alpha equals 0.01 level of significance to conclude that, and then our alternative hypothesis is a majority of people believe that the Loch Ness Monster exists. We are in section 8.3, testing a claim about a mean. It is very rare that we test a claim about an unknown value of a population mean mu, but we somehow know the value of the population standard deviation. When the standard deviation of the population is unknown, the test statistic has a distribution called the student's t-distribution that we saw earlier. And the test statistic for testing a claim about the mean is going to be t equals, and it's our x value minus our mean. And then remember that our standard deviation changed, and it's s divided by the square root of n. Right below this, we have our steps for how to use the graphing calculator. And this is going to work with an 83 or 84 calculator. Again, if your calculator is a little different, make sure to write down notes so you know how your device works. So use the following steps provided that, and here's what we would have to test. First thing is our sample needs to be a simple random sample. And the second thing is that the population is normally distributed, or the sample size is going to be large. And we say large is going to be greater than or equal to 30. Step 1 is going to be determine your null and alternative hypotheses, which again is dependent upon two-tailed, left-tailed, right-tailed test. Step 2 is going to be select your level of significance, alpha. This is usually given to us. If it's not, then you get to select it yourself. Step 3 is find the p-value. So in order to do that, we're going to go to Stat button on our calculator, go to Test, and then find t-test. If raw data is given, highlight data and put the list into L1 and frequency set to 1. And then if summary statistics are given, highlight stats. Mu naught is going to be the value of the mean stated in the null hypothesis. And then you need to select the direction for your alternative hypothesis. It's either not equal to, less than, or greater than that value of mu naught. Highlight calculator, draw, and press enter. The output that we're going to get, the two values that we will need, are going to be t, which is our test statistic, and p, which is our p-value. And again, using that p-value approach, if the p-value is less than alpha, we reject our null hypothesis. And then again, we need to state a conclusion. So the example on the next page says, in 1990, the mean height of women 20 years of age and older was 63.7 inches based on the data obtained from the CDCI and the Prevention's Advanced Data Report number 347. Suppose that a random sample of 45 women who are 20 years of age or older today results in a mean height of 63.9 inches and a standard deviation of 0.5 inches. Part A says, is the criteria met in order to perform this test? And so since we're dealing with mean heights, we are dealing with a parameter of mu. And so we only have to check two things. First thing is this is a simple random sample. And since they're just randomly selecting people, we know it's a simple random sample. And then it also says that our sample size, which is n, is 45 women. And since this is greater than or equal to 30, we can say check. There's only two things that we have to check in order to perform this test versus when we have a parameter of a proportion instead of a mean. So part B says to state the appropriate null and alternative hypotheses. And it does say on here to assess whether women are taller today. So since we're talking about average height or the mean height, I'm going to go ahead and put mu. An equal sign is always for our H naught or our null hypothesis. And that height that we are looking at is what they found in 1990, which is 63.7 inches. And now they're asking for if they're taller today. And since taller would be greater than or larger than that 63.7 inches. Part C says use the p-value approach to test the claim that women are taller today. And so for this problem, we have to go to our calculator and go to t-test. And when we do t-test, it's going to ask for a lot of information. And so one of the things that it's going to ask for is x bar, s, and n. And we know n is 45. X bar and s are from your sample. And so from the sample, we have that our height was 63.9 inches. And our sample standard deviation is 0.5 inches. On your graphing calculator, go to Stat, Test, to T-Test, and you need to enter in mu naught, x bar, sx, and n. And then your alternative hypothesis is going to be greater than, so make sure that you have mu greater than mu naught. From this, you'll get your p-value. Again, remember rounding in 4 decimal places because it's a probability, and we'll get 0.0051. We get a p-value equal to 0.0051. And we need to compare this to alpha. And for this problem, if you notice, we don't have an alpha value given to us. And this is going to happen sometimes for us, and it will definitely be happening with your project. You're not going to have an alpha value given. And so we're just going to assume that alpha is equal to 0.05. That is the most commonly used alpha value. Dealing with significance and things along those lines too is why it shows up a little bit more. However, it is up to you. If you wanted to pick 0.01, you could, or 0.10, you could, or 0.07, you could also. But remember, this is the probability of a type 1 error. And so our p-value is going to be less than our alpha value, which is 0.05. And since that is, we're going to reject H naught. And then we need to write our conclusion. And so for our conclusion, we would say there is sufficient evidence and it's at the alpha equals 0.05 level of significance. To conclude that, and we were looking at to see if women are taller today. So this is taller today than they were in 1990. So to conclude that women are taller than in 1990. So the example right below this says to test H0, which is mu is equal to 4.5, versus H1, which is mu is greater than 4.5. A simple random sample of size n equals 13 is obtained from a population that is known to be normally distributed. Part A says if x bar is equal to 4.9 and s is equal to 1.3, compute the test statistic. So in order to do this, we need to go to t-test on our graphing calculator to get our test statistic and our p-value. We are going to go to stat, to test, to t-test, and we need to enter in our mu naught value, which was given to us as 4.5, x bar, which was also given to us in part A as 4.9, s is 1.3, and our sample size is 13. All of these values were given to us. In addition, our alternative hypothesis is greater than, so make sure to select that. Once you have that, select enter. You will see that you have t equals and a p-value. So t is going to be our test statistic for this distribution, and then p is going to be the p-value that corresponds to it. From the calculator, we get our test statistic, t is equal to 1.109. And we also got the p-value, so I'm going to just jot down the p-value down here with part C. So our p-value is equal to 0.1445. And really quick, our sample size, since it is so small, it's less than 30, that is why this states that we know that it's coming from a population that is normally distributed, and that's because our sample is small, it is less than 30. So part B says to draw a t-distribution with the area that represents the p-value shaded. So let's draw our t-distribution. Remember, the t-distribution is bell-shaped, but it is a little bit wider, more spread out than that z-distribution. Our mean is still 0 for t, and the test statistic that we have from up above is 1.109, so I'm going to go ahead and put that on my graph. We are dealing with a right-tailed test, and so I'm going to go ahead and shade this right tail over here, and that area that we shaded is our p-value, and so this is going to be 0.1445. Part C says to approximate and interpret the p-value. So we have already written down our p-value, and so to interpret this, we would say we would expect about 14.45% to have a mean of 4.5 or more. Part D, right below this, says if the researcher decides to test the hypothesis at the alpha equals 0.1 level of significance, will the researcher reject the null hypothesis, and why? So our p-value here that we found earlier is 0.1445, and comparing this to alpha, which we have stated in the problem is 0.1, we can see that our p-value is greater than alpha, which means we do not reject H0. And we can write a conclusion here, but the researchers are not going to reject H0 at the alpha equals 0.10 level of significance, and it's because the p-value is greater than alpha. So it does ask for y here, so, and we can say because the p-value is greater than alpha. The example on the next page says, do students who learn English as well as another language simultaneously score worse on the SAT critical reading exam than the general population of test takers. The mean score among the test takers on the SAT critical reading exam is 501. A random sample of 100 test takers who learned English as well as another language simultaneously had a mean SAT critical reading score of 485 with a standard deviation of 116. Do these results suggest that students who learn English as well as another language simultaneously score worse on the SAT critical reading exam? Part A says to state the appropriate null and alternative hypotheses. So H0 and H1. Since we're talking about it's not a proportion, this is a means problem, the mean score. So we're going to have mu's here for our null and our alternative. The null does get an equal sign, and then we need to write down the score for the population, and that score for the population is 501. That's for everybody taking the SAT critical reading exam, and so it'd be equal to 501 here. And we're saying, do students who learn English as well as another language simultaneously score worse than on the SAT critical reading exam? So we're assuming that their score would be less than 501. Part B says to verify that the requirements to perform the test are using the t-distribution are satisfied. And yes, we have a simple random sample, as stated. And we also have a sample of 100 students, and that is greater than or equal to 30. So both of those requirements are met, therefore we can perform our test. So part C says use the p-value approach at the alpha equals 0.1 level of significance to test the hypothesis in part A. So in order to do this, we know what mu naught is. That is 501. Our sample mean is 485. And our sample standard deviation is going to be 116. Again, we would be using t-test. On your graphing calculator, we're going to go to stat, to test, and to t-test. From there, we're going to enter in our mu naught value, which was 501, our x bar, or the mean of our sample, which is 485, Sx, which is our sample standard deviation, which is 116, and then our sample size, which is 100. Select the alternative hypothesis, which is a less than your mu naught, and select enter from there, and you should get a p-value along with your test statistic. The p-value that we have would be 0.0855 if we round 4 decimal places. So from the calculator, we get a p-value equal to 0.0855, and we need to compare this to alpha, and alpha was given to us as 0.1, and so our p-value is less than alpha, and so this means we are going to reject H0. So part D says to write a conclusion based upon your results in part C. So for this, there would be sufficient evidence. So there is sufficient evidence at the alpha equals 0.10 level of significance to conclude that, and then we always write down what we are testing, which is our H1, and this is going to be that students who learn English as well as another language simultaneously score worse on the SAT critical reading exam. So to conclude that students who learn English as well as another language simultaneously, I'll abbreviate that, score worse on SAT critical reading exam. And again, you always put in your conclusion that alternative hypothesis, which is that the mean is less than 501. And you need to write about it in the context of the problem. The example right below this says, data collected on earthquakes lists the earthquake steps, and the summary statistics are, sample was 600 earthquakes, x bar is 5.82 kilometers, and our standard deviation is going to be 4.93 kilometers. So use a 0.01 significance level to test the claim that earthquakes are from a population with mean equal to 5 kilometers. And it says assume the criteria has been met to perform this test. And so first thing we need to do is state our null and our alternative. And we are dealing with how deep these earthquakes are, which would be an average or a mean. So I'll go ahead and put mu, an equal sign for H naughts. And from our population, we know that the population has a mean equal to 5. And I'll just put the 0 zeros in there. You don't have to. And then for our alternative, it doesn't say less than or greater than. So again, we're going to go ahead and put not equals to that 5.00. And so we're going to have to use t-test and put in all the information that is given to us up above. From the calculator, we get a p-value equal to 5.24 times 10 to the negative 5th, which if you move your decimal place 5 times to the left, it's 1, 2, 3, 4, 5. Put a new decimal there. So this is going to work out to 0 point, and you have 1, 2, 3, 4 zeros, 5, 2, 4. And then again, we usually round things for our probabilities to 4 decimal places. 5 would make that 0 become a 1. And we are given alpha. We know that alpha is 0.01, and this is smaller than alpha, which is 0.01. And since our p-value is less than alpha, that means that we are going to reject H naught. So we can say there is sufficient evidence at the alpha equals 0.01 level of significance to conclude that, and we can say that the mean depth of earthquakes is different than 5 kilometers. So that the mean depth of earthquakes is different than 5 kilometers. Right below this it says practical significance, and this refers to the idea that while small differences between the statistic and the parameters stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. Large sample sizes can lead to results that are statistically significant, while the difference between the statistic and the parameter in the null hypothesis is not enough to be considered practical significance. So we have an example on the next page, and this one says, Michael enrolled in a course that is designed to increase reading speeds. Prior to enrolling in the class, Michael read 198 words per minute, and the following data represents words per minute read for 10 different passages he read after the course. Part A says because the sample size is so small, and our sample here we only have n is equal to 10 passages, which is definitely less than 30. And so it says how do you determine if data comes from a population that is normally distributed. So there's three things back in section 6.5. So I'll put down section 6.5. And we have to do this for our own personal projects. But the first one is that we would make a histogram, and our histogram, it needs to be roughly bell-shaped. And we could do that with those numbers. So roughly bell-shaped. Second thing that we have, we are not allowed to have many outliers. So I'll go ahead and put down they should not have any outliers. Usually allowed to have like one. The third one is that our normal quantile plot needs to be approximately a straight line. So our normal quantile plot is approximately a straight line. Part B says, was the class effective? Use the alpha equals 0.10 level of significance. So in order to test this, we need to first write down our null and our alternative hypotheses. So we're talking about reading speeds, and so we would say the mean reading speed. So I'll put muse, an equal sign here. And it does say that Michael read 198 words per minute prior to enrolling in the class. So this would be that it would stay at 198. But it says, is the class effective? So if it's effective, that means that he improved his reading speeds. And so he'd be reading more than 198 words per minute. So for this, we need to use t-test on our calculator. And a little different here because we don't have those statistics. So for our t-test, we actually need to use the data option. And we need to put all these numbers up here into L1. So once we have our list in, we need to make sure our mu naught is equal to 198. Our list would be L1, and then our frequency would have to be set to 1. So on our graphing calculator, we're going to go to Stat, to Edit, and we need to take a moment to enter in all of the values that we have into L1. Once we have that, we need to go to Stat, to Test, to T-Test, and you need to select Data instead of Stats. And once you select Data, you'll notice that you'll be asked about the list and your frequency. Your list, I put my numbers into L1, and my frequency is going to be set to 1. My mu naught value is 198, and my alternative hypothesis is going to be a greater than. So I need to make sure I set it to be greater than mu naught. Once I do, I get my test statistic and my corresponding p-value. The p-value that we have running 4 decimal places will be 0.0033. Then from the calculator, we get a p-value equal to 0.0033. And this is less than alpha, which is 0.10. And so this means we are going to reject H naught. And so in conclusion, we would say there is sufficient evidence at the alpha equals 0.10 level of significance to conclude that the class is effective and that the reading speeds increase. So in plain English, was this course effective? And since we rejected our H naught, which meant this is not what we're going with, we can say that yes, it was effective, that it was able to improve Michael's reading speeds. And this is data that this company can use to show that their class is effective.